Hello and welcome to the University of Strathclyde Eco-Vehicle team's introductory video. USEV is a team of over 110 students from a variety of engineering disciplines in year groups, and our focus is on designing an ultra-efficient prototype battery electric vehicle.
We've moved away from a composite body supported by an aluminium frame and decided to dedicate a lot of work to developing a carbon fibre monocoque. We've managed to improve the aerodynamics by more than 30% using CFD simulations and performed FEA testing to prove the component strength. As this is a big financial and time investment, the monocoque is being designed to have a longer service life than anything we've produced before. We are updating our Pitman arm steering to a rack and pinion. This should reduce slack and provide a smoother control for our driver. After prototyping last year, we're confident in producing a front wheel hydraulic pedal brake to comply with the marathon's regulations this year. Since we are now producing a monocoque, the chassis has been reduced to a frame mounted at the back of the bulkhead for the rear wheel and electronics. The aluminium extrusion we have used in the past has allowed us to develop our skills in chassis design, but this year we've decided to move to a single welded steel part which can be removed with ease from the monocoque. Smaller, lighter and smarter mounting solutions is the goal.
One team that has really benefited and grown in both size and ability is Telemetry. This year the team aims to provide meaningful information in real time. They plan to do this by decoding the information sent on the car's internal CAN bus, then transmit this data through a server to the trackside team. This will allow potential issues to be discovered before they happen. We're also planning on adding a driver screen with critical information as well as implementing sensors such as a GPS, gyroscope and accelerometer. Off the back of last year's battery innovations and the insight of telemetry data from previous years, we were able to confidently reduce the capacity of the battery, providing a lightweight yet high performance pack. To accommodate for the increase in system voltage, the series cell count has increased to 12, providing a nominal 44.4 volt output. The battery management system has been re-engineered from the ground up for increased reliability and efficiency. It'll be based around an all-new active cell balancing controller from Analog Devices and an STM32 ARM-based microcontroller. This will allow for greater capacity utilization and more flexible control compared to its predecessor. The research and development team has been restructured to include both an electrical branch and a mechanical branch. This allows a broader variety of projects and will mean there is the support in place for engineers of varying disciplines. New and exciting electrical projects include the development of a voice-activated communication system between the driver of the car and the team, and the development of a dyno to create a safe platform for testing different attributes of the car in the lab. The powertrain team this year has a large budding talent pool to draw from, which has enabled us to concentrate resources. An example of this is in our endeavour to gain a better understanding of the performance, energy use and behaviour of our vehicle. We're expanding the scope of telematics data, which we are collecting from each sub-team within the vehicle. This poses additional communication challenges and increases communications latency between modules in the vehicle. So an additional CAN bus network has been introduced to accommodate this increased demand, and all critical nodes move onto a separate critical network, where a highly optimized communication scheme provides low latency, reliable and recoverable transfer of data between critical nodes, such as the body controller, driver interface, battery management system and motor controller. The team will be moving towards a three-phase brushless DC motor and associated motor controller to offer increased efficiency and control of the physical performance of the vehicle. This will be based on the lessons learned in our previous brushed motor and motor controller, using telematics data to inform both the machine and controller design. Similar to our previous controller, it will be based on an STM32 microcontroller, but will use a faster device to support the additional processing needed, as well as using a new range of smart gate drivers to reduce weight, component count and physical size.
We pride ourselves on our ambitions and are excited to continue our journey by developing both our eco-vehicle and as a team. Thanks for watching.